Welcome to our final tutorial in this series. Let's get started on our list of to-dos. We'll start by refactoring the main.dart file by removing unused code. We'll then make the switch screen our home landing screen. I'll show you an easy way to import the switch screen file into the main.dart file. Next, we'll go into the Linux folder, open up a file, and change our default app screen size. With all of that done, we'll build and test the app on my Raspberry Pi development system. I'll show you what files you need to have to run the project on another embedded system. After moving the files, we'll run the app and test it on my Raspberry Pi with a touchscreen. If you have created your project, you probably have this boilerplate code like this in the main.dart file. We'll start by changing the title. Feel free to call it whatever you like. Next, we can remove these comments and we'll keep the theme as is. I'll collapse these classes and delete them. Make sure you delete everything or you will get some strange errors later on. We don't need this text for my homepage anymore, so we'll delete it. If you have already created the switch screen class and Dart file, you can highlight my homepage and start typing switch. As you are typing, you'll see a list of suggestions. Select the switch screen option, and VS Code will automatically import it into the main.dart file. If you don't want the debug banner showing, go up to the Material app, as I am doing, and start typing debug, and you should see a list of suggestions. Select Debug Show Checked Mode banner, and then type false. Be sure to save your file. Now go to the File Explorer and find the Linux folder, as I have done. Open the My Application file and scroll down to line 50. Here's where we can set the default pixel size of our app. I have set it to my touchscreen size of 800 by 480. Now that we have completed our coding, it's time to test the app. We'll first use debug to test our app on the development system. Now that we have tested our app, we'll build our release version. I'll next show you how to find the bundle folder and move it to a USB drive. Next, we'll load the files on the touchscreen Pi. After loading the files on the micro SD card, we need to change the file execution permission. Now we can run the program and test. To run and debug, you can either use the keyboard shortcut or click on the debug icon and then click on the Run and Debug button. On my Raspberry Pi development setup, the process can take a few minutes. In this tutorial, I've gone ahead and cut out the processing time for you. On your setup, when you are building for Run and Debug, you can watch the status down in the lower right corner. When the Run and Debug process is complete, you'll see these lines in the debug console. Then, the app screen will start to appear. Our app is responding to the switch state changes as expected. When the switch goes to 0 volts, the GPIO pin state changes to 0 or false. When the switch is open, 3.3 volts, the GPIO pin state changes to a 1 or true. Now we can move on to building the release version of the app. On my Raspberry Pi development setup, the process can take a few minutes. In this tutorial, I've gone ahead and cut out the processing time for you, and will come back in when the build is complete. As I've highlighted, the Linux app release build is located at the file location shown. Let's use the Raspberry Pi file manager. and find the bundle folder. We will need to copy that folder, put it on a USB thumb drive, and then we can transfer it to my other Raspberry Pi with a touchscreen. I am still getting used to the Raspberry Pi file manager. I didn't know you can't copy in this window. That's more like it. Finally figured out how to copy it. Now that we've copied the bundle folder with all of the files onto the USB thumb drive, we can eject the drive and head over to my Raspberry Pi with the touch screen. I assume that you have watched part 1 of this series and have built and tested your circuit. Here is the circuit schematic, wiring diagram, and Raspberry Pi pinout. You can also find in the intro video the circuit schematic, wiring diagram, and Raspberry Pi pinout at about the 2-minute and 20-second mark. After loading the bundle folder with all of the files we'll need, we need to change the permissions for the switch demo file. By default, the file cannot be executed, so we need to change that permission to anyone can execute the file. Double-click and choose Execute. Our app is responding to the switch state changes as expected. When the switch goes to 0 volts, the GPIO pin state changes to 0 or false. When the switch is open, 3.3 volts, the GPIO pin state changes to a 1 or true. Thanks for watching. That wraps up our Flutter-embedded Raspberry Pi GPIO read a switch tutorial. With these building blocks, you can now create your custom IoT embedded app. The source code for the project is located in my GitHub repository. The link is in the description. See you in the next tutorial, and don't forget to send us your comments and suggestions